So I apologize for the quality of the editing on this video. I don't have access to my office right now. But let's talk about how to calculate that Gini coefficient. I have income here broken up into quintiles for equality, where everybody has the same amount of income. See, each quintile has 20% of the income. Or we have a less equal situation and a very unequal situation. I'm going to draw them all out on the graph and calculate the Gini coefficient for all of them. So for equality, the first quintile has 20% of the income. The first quintile moves you 20% over on the population axis, and if we go up to a height of 20% of the income, we are now constructing our Lorenz curve. That'll be the first step. Now, when we get to the second quintile, they also have 20% of the income, but that's a marginal 20%. So we have to add that 20% to the first 20%. We get 40% of the income when we're in the second quintile. Go to the third quintile, you're up at 60%. The next quintile, you move up to 80%, and you're always going to end with your last quintile. After you add everything up, you have to account for 100% of the income. So now, if you connect these dots we just made, you will have your Lorenz curve. And you'll notice that that Lorenz curve is on the line of equality. We have zero inequality. But let's go ahead and calculate the Gini coefficient for that. So the way that we're going to do that is start by calculating the area beneath the Lorenz curve. So you'll notice this first quintile we can always calculate as the area of a triangle. So let me do that for you. We have 1/2, and then the base is 0.2, and the height is 0.2. So if you work that out, you'll get 0.02. Now, when you move over to the next quintile, it's no longer a triangle. You have, if you're trying to calculate this additional area, that's a trapezoid. There's two ways you could do this. You could break it into the bottom square and the triangle on top of that, or you could just take the area of the trapezoid, which basically involves finding the midpoint of the heights. So halfway between 0.4 and 0.2 is 0.3. And when you do that, you're calculating 0.3 times your width of 0.2. And so you're adding in this area that's not really there, but you're leaving out this other area that should be there, and those will balance out. So I'm going to erase all this stuff that I just drew. And we'll go to the calculation. So the calculation for the second quintile is 0.2 is the width times, well, it's not a height of 0.2, it's not a height of 0.4, it's halfway in between there. So we are going to multiply that times 1/2 times 0.2 plus 0.4. So if you work that out, you will get 0.06. Go to the next quintile. Its width is also 0.2, and we're going to multiply that by the average height here, which you can see is 0.5. The way that I would calculate that is 1/2 times 0.4 plus 0.6, and if you crunch those numbers, you get 0.1. Now you may be seeing a pattern. When we go to calculate for the next quintile, the width is 0.2 times the average height is 0.6 plus 0.8. And if you crunch those, you get 0.14. And then finally, the last quintile, 0.2 times 1/2 of 0.8 plus the last number is always 1. So go ahead and crunch those out and you get 0.18. So if you add up all these numbers, you end up with 0.5, and that is equal to your Q. Your Gini equals 1 minus 2 times Q, so 2 times 0.5. So 1 minus 1 is 0. The Gini coefficient tells you how unequal a country is. A bigger number means more unequal. 0 means that we have perfect equality. So let me erase that example and move on to the next one, where we have what I've called less equal. You can pause the video here and get these numbers because I'm going to erase the space so that we can work through the next example. The next example we have in red, and so I will draw it in red. First, let's start with the Lorenz curve. The first quintile has 10% of income, so 10% is about that tall, so put that on the first 20% of the population. Next, the second quintile has 15% of the income, but remember that's a marginal 15%, so 0.1 plus 0.15 gives us 0.25, which is about there. This isn't rocket science. Feel free to draw this on graph paper, something where you have more precise lines, and that makes it look neater. Now go up to the next quintile. They have 20% more than that, so that puts us at 0.45. The next quintile, add 0.25 on top of that, we get to 0.7. And remember that the final dot on your Lorenz curve is going to be in the upper right corner. 100% of the population, by definition, has to have 100% of the income. So to make our Lorenz curve, I'm just going to connect the dots. We also had this point that I didn't really talk about. 0% of the population has 0% of the income, also by definition. So we'll just make a couple of lines. Basically, each one of these dots we're going to connect with a straight line. Now, if you had decile information, so you had 10, 30, 50, etc., and we had 10 groups, then that line would be a little less choppy, a little bit more smooth. In the limit, you could get a continuous curve, but that takes a lot longer to calculate, and on an exam or something, we're not going to ask you to do that many calculations. So once again, let's get the area under the Lorenz curve. That's going to be Q. The first one, we have this triangle. So the area of the triangle is 1/2. The base is 0.2. The height is 0.1. So if you work that out, you get 0.01. Next up, it's a trapezoid again. The width is 0.2, and the height is the average of 0.25 and 0.1. Now, notice, if you look at these numbers that you have put on your income axis, those are going to be numbers that pop up in your calculations. So the width here is 0.2, and we're going to multiply that by the average of 0.1 and 0.25. When you work that out, you get 0.035. The next quintile, the width is 0.2, right? 0.6 minus 0.4, it's a quintile. That means 20%, times the average height here is 0.25. Whatever the last number was here is going to be the first number here. So that's one way that you can work through the calculations a bit quicker. So add that to 0.45. And when you calculate that, you get 0.07. The next quintile with a 0.2 times the height is the average of 0.45 plus 0.7. And that works out to 0.115. And finally, 0.2 times 1/2, that's the last quintile here, of 0.7 plus the final number is always 1. And that's going to equal 0.17. So if you add all of these numbers up, you are going to get 0.4 is your Q. So your Gini equals 1 minus 2 times 0.4. So 1 minus 0.8 gives you 0.2 as your Gini coefficient there. So you have a little bit more inequality. You can see that there is some more area creeping in here between the Lorenz curve and the line of equality. Right, well, there was 0 area there before. So keep that in mind. Take a screenshot of this or whatever. We will move on to the very unequal example next. Give me just a second to erase this stuff. Again, I apologize for my lack of editing skills right now. I can't get onto my office computer, so everything is being done from my iPad, and I'm trying to get you the answers as quickly as I can and it usually takes me longer to edit a video than to draw it. All right, finally, let's do this very unequal example. And the first quintile only has 3% of income, so something like this, 0.03. The second quintile has 7%, add that to the 0.3 and you get 0.1 for the second quintile. The next quintile has 10% more than that, so we go to 0.2. The next quintile has 0.15, so we end up at 0.35. And then the final quintile, we're going to end with 100% of the income. So go ahead and draw in your Lorenz curve, really tiny for that first quintile. Bump it up there, there, to there, and mine might not be perfectly to scale. But you can see here that there is a lot more area between the line of equality and our Lorenz curve. So I'll back that out. And we can go through the calculation one more time. Remember, the first part of our Lorenz curve, we have a triangle. So 1/2 of that base is 0.2 times the height is 0.03. And if you multiply those all together, you get 0.003. In the next quintile, we have a trapezoid. The width is 0.2. The height is, we're going to take the average height here between 0.03 and 0.1. And that gives us 0.013. The next quintile over, the width is still 0.2. Those widths should be the same, no matter if you have quintiles or deciles or whatever. Those widths should be the same number. All right, we go from 0.1 to 0.2, and that gives us 0.03. Then next quintile, 0.2 times the average of 0.2 and 0.35, and that gives us 0.055. And then finally, the last quintile, we have 0.2 times 1/2 of 0.35 plus 1, and that will equal 0.135. So if we add all of those numbers up, we get 0.236, and that's equal to Q. So our Gini is equal to 1 minus 2 times 0.236, which gives us 0.528. You see that's a bigger number for the Gini coefficient. It is more unequal than the previous examples. I hope that helps. I am here for any questions that you still have.